Okay, hola. I've been told it's not bienvenidos, it's benvingut, is how you say it in Catalanian. So, welcome everyone. My name is John Studarus. Today we're going to be talking a little bit about edge infrastructure and experiences deploying out software across some brand new spectrum available in the United States and some edge locations we've been turning online here. Oh, to start here, we have some interesting graphics all about all the technologies that are making up 5G and all the players in there with the CNCF leading the way. Okay, so I call this presentation "The Edge is Open." Part of it is the fact that there is so much open source and so much open technology involved in all this. We're going to see this across the way, how the edge computing is opening up to commoners. It's no longer the walled garden we're seeing anymore, and making it available for businesses to use. Most of all, it's open for improvement. So my experiences so far, at least on the software side, is not everything is there that we need. So a lot of the algorithms that are available in Kubernetes and OpenStack don't quite cut it yet. And so I've got some ideas. And this is a BOF, so it's supposed to be an informal and get participation from the audience. So I'll save some time at the end. I also want to hear people's feedback on this and how to get everyone else involved in all this. Quick overview, it's a slide I sold from OpenStack Summit, I think, a couple of years ago, where China was talking about what edge computing is all about. For those of you that aren't aware, data centers, we got our centralized data centers. Then as we move closer to the user, we have switching facilities used by telcos. And then as we get closer and closer, we get cell towers. And as we get closer to those end users on those mobile devices or self-driving cars, latency goes down. And that's what we need for these new killer applications that are being driven by 5G, self-driving cars, need ultra-low latency. And so we need to move this compute as close as possible to the end user. So when we talk to people, and even at this conference here, what is the definition of edge computing? So we have some people envision that it's on cell devices, that it's ultra small versions of Kubernetes that we're installing on edge devices. Is it mobile towers, mini towers that are being driven around on trucks, or is it traditional cell phone towers with computing infrastructure moved in? We'll talk about that more in a little second. And getting on more about why do we need to move stuff to the edge? Well, prime example, one of the killer applications is self-driving cars. We're going to have self-driving cars out there. They're going to be able to talk to each other. They need to be ultra-low latency so that the data between all the cars gets passed back and forth so the cars can respond quickly enough. And not all the data, not all the compute power is going to be available inside the car. So we're going to have compute somewhere close to the cars alongside the road, easy for the cars to connect to and for the cars to communicate across. So. This is a presentation from IFX. It's an edge computing conference done every December at the same time as AWS. So their definition of what edge computing is, it's where the digital and physical worlds interact. So where physical locale is important, so really as close to the end user as possible. Okay. So let's talk a little bit about what we're seeing in these edge locations and how they're becoming open source and open technology. So the locations that we're going to see a little bit more about. ARM processors, we're seeing them rolled out in edge locations. ARM is a open source processor design, originally designed for cell phones. They're great for edge locations because they're low power, high core count. Low power is critical in edge locations because we're dealing with limited amount of power, limited amount of space, so we need to have as much compact computing power as possible in these locations we're turning on. And the lower power that you can do, the higher density you can do, the less air conditioning you need. And oftentimes these edge locations might not have very much in the way of air conditioning. So we're seeing a lot of ARM processors. And we're seeing a lot of standardization in the actual cages and the racks and the cabling that all of this equipment is being put into. Since these edge locations are becoming open and they're no longer these controlled environments by telcos, we need to make it available for anyone that wants to come into and ship some infrastructure in. We want to make it easier for them to just ship in and roll in a single piece of equipment It's not going to be staffed by people, so it's going to be a FedEx guy rolling out once a month to swap in and out equipment, so it needs to be easily swapped in and out. So we're seeing a bunch of open standards available. So the Open 19 Foundation, they're involved in standardizing a lot of the cabling, a lot of the rack formats, and then the Open Compute Project, started by Facebook, is standardizing a lot of the server frameworks, the motherboards, and the networking infrastructure. So. And then the containers that are being deployed. So this is a container conference, interesting enough. We're using shipping containers, and those are being deployed at these cell phone towers. So Vapor.io, they've been busy building out these containers and also providing the backhaul connectivity from the cell tower locations and back out to the internet. So these are half-size shipping containers, full-size shipping containers, loaded up with equipment and then connected into the cell phone towers. So let's talk about the spectrum that's being connected onto it. Traditionally, at least in the States, spectrum has been auctioned off by the federal government and made available to the telcos. So it ends up being a very controlled environment. The telcos own the spectrum, and it ends up being expensive, both for the telcos to purchase the spectrum and then also as for an end user to gain access to that spectrum. In the States, things have changed around a little bit. There's some new spectrum becoming available. It's CBRS, it's called Citizen Broadband Radio Service. It's a 3.5 gigahertz spectrum. It's very similar to 5G. However, it's not sold to the telcos. It's freely available. You can buy CBRS-enabled devices that will use this spectrum. You can use it with lower class antennas if you want to use it within a office setting. You can get with larger antennas for use to connect to a cell phone tower. Just by using CBRS, you're not going to get internet connectivity, right? It's just going to be something you can use much like a Wi-Fi to create your own environment, but there's nothing to say you couldn't connect it on to a cell phone tower and have your own connectivity out. Maybe if you're using CBRS, you don't even need internet connectivity because you're just connecting to one of these shipping containers that's at a cell phone tower with a CBRS antenna attached onto it, and then the car or whatever device that you have is using CBRS connecting back to the antenna and using the compute power at that cell phone tower, so there's no need to even backhaul it back across an internet connection. So CBRS, currently there are locations enabled at Foxborough Stadium, which is the home of the Patriots and the United States football team. So football stadium, Las Vegas along Miracle Mile Mall, huge mall within, so retail use cases there. Chicago, downtown Chicago, there are a number of installations, about 12 other locations turning on, and the spectrum should be available hopefully by nationwide by the end of this year in the United States. So people ask me, is this spectrum going to be available overseas? Are other governments going to release it? And from what I've heard is they're wanting to see how well it goes in the States, and then hopefully they'll adopt the same model overseas. So the spectrum could be become available overseas as well. So this is a team play, making CBRS available along with the cell phone towers. So we've got the cell phone tower operators. They're the ones that own the physical land at the cell phone towers. They're the ones that own the antennas. Traditionally, this used to be the telcos, and now they've sold that land and the antennas to these real estate investment trusts. So Crown Castle, American Tower, SBA, they're major players in the U.S. and Central and South America. So they're the ones that own the space. Then we see companies like Federated Wireless. They're the ones that are the overseers of the spectrum, and they're the ones that certify devices that use CBRS. And they also have sensors that monitor the spectrum. And then we have companies like Packet. They're a bare metal service provider. They're the ones that provide physical infrastructure that you can rent by the hour that are co-located within these cell phone towers. So it's a combination of all of these that make the spectrum available. You can buy the devices from traditional channels that have CBRS enabled, rents the infrastructure from a company at Packet, select which edge locations you want, tie it into the CBRS antenna at that edge location, and bingo, you've got yourself some edge computing at a container environment that's connected back to your devices. So we'll talk a little bit more about my experiences going out and deploying software across those. So here are a couple of pictures of the first ones being installed. This is the one in Foxborough being installed at a Crown Castle location. If you are interested in learning a little bit more and actually coming in and testing and you have software, that's sort of I'm a software guy, so I spend a lot of my time software testing. I am looking for other companies that are interested in testing out and using some of these edge locations. So there is an Edge Alliance program. Feel free to talk to me about that, and we can get you access to some of these. I really want to get more experience. This is a BOF session. I want to get more feedback from people and get people involved in trying out these locations. So here are just a couple more slides showing a location with the antenna with all the antennas installed on it, and just sort of the equipment that's inside of it. Okay, so enough of the hardware. Let's talk a little bit about the software that's making this all happen. So on the software side, we've been doing some work building out CubeSpray. We put in some releases into CubeSpray so we can automate out the installation and turning on of the hardware. So CubeSpray, for those of you who don't know, it's a manner of deploying Kubernetes. So we've been deploying Kubernetes across these installations using CubeSpray. It automates the full process of provisioning the hardware and then turning on the clustering. So the full cluster is available. We'll be doing a little bit with work with Rook as well, turning on persistent storage on there, and that's been working great. We've also been working with Starling X on the OpenStack side, working with them to get some of their software installed and running on these edge locations, and then doing some initial talks with a couple of other players in the Linux Foundation. One of the software systems we've been playing with is a open source video conferencing system. This is interesting for us. We're looking for what those killer applications are that are ultra low latency and latency sensitive. So Jitsi was one. Just ran across it. It's an open source system. We can run in containers. We can run on VM. We can run on bare metal. So a bunch of different installation mechanisms. And the idea is what's the best way to go and deploy something like Jitsi to support end users? One of the features Jitsi has is this cascading solution. So if you start up multiple server-side instances of the software, it'll peer the servers together to backhaul the video streams back and forth across the locations. So then it comes down to me as an operator of this software. Where do I want to turn on these instances? Do I want to turn, which edge locations do I want to turn on? Where are my end users? And this is actually one of the key problems we're finding is, where do we turn on these? Which edge locations do we turn it on? The Kubernetes scheduler doesn't keep track of where your end users are, and it doesn't keep track of where to deploy the software to keep latency really low, because that's our goal. We want to run the edge application at one of these edge micro data centers to keep latency ultra low to the end user. The Kubernetes scheduler is interested in deploying and to where computing resources are available, and we want to deploy it where the end users are and how we can keep latency ultra low. So this is just a little bit about the performance gains you get by using that server cascading, the feature. So we really want to get the application running at the best location possible. So then it probably becomes a little more tricky. What do you do when the user is driving down the freeway? Right. So he's using one edge location now. He's driving down Highway 5. A couple minutes later, he's no longer at that cell phone tower. He's at the next cell phone tower. What does our edge application do? We need to have some sort of scheduler that's going to be smart enough to say, he's driving down Highway 5. I need to turn on a container with the application running a couple of miles down the freeway, a couple of miles after that down the freeway, and maybe turn the old one off. How many users are there within a region? Okay, you've got 10 users within this region in downtown New York. Let's go ahead and turn on an instance at that edge location. And by instance, it could be a container, it could be a VM, it could be a bare metal instance of the software. But the middleware, the cluster management software needs to go through and keep track of that. And the problem's just going to get more difficult. There are going to be hundreds and thousands of these edge locations turned on. And they're all going to be connected to different types of wireless spectrum. Some of them are going to be connected to CBRS, some of them are going to be connected to 5G from different providers. Your end users are going to have different types of spectrum available on their edge device. Maybe they're not going to have CBRS. Maybe they're going to be connected to a different telco. So we're going to need to have some sort of mechanism of tracking those users, where the users are, what connectivity they have, what are the latency requirements of those end users, and feed that back into the system so that the middleware layer goes through and deploys the application. So from a software side, our experience is going through, these are the sort of things that we would like to see improve from the edge systems. So some type of service registry when software gets deployed, where it is, which edge location is it at, what type of spectrum is it connected to, where are the users, these are things that I mentioned before, and then tie that into the application. What are the application requirements? How low latency does the application require so that the scheduler knows when it goes and it deploys the software? How many instances of it does it need, and how close to an edge location does it need to get that user to? And when to scale it up and when to scale it out. So when to scale up additional containers within one edge location and when to go ahead and turn on multiple edge locations and ultra locations there. So like I said, we do have Packet does have an Edge Alliance program, so if you want to get access to some of this infrastructure, interested in trying it out, if you're working on some sort of clustering software or enhancements to Kubernetes or some type of application, we're happy to work with you and get you support and get some feedback so we can work together on improving this. So hopefully all together we can help build a better internet here. So like I said, this is a bird of feather session, so it's supposed to be informal. It's not quite the setting to do an informal discussion, but I'm open to take questions or get other people's feedback on how they've been working on edge computing with this technology. No questions? Okay, I got one done. Do we have a microphone? I'll just repeat it. Go ahead. Uh-huh. So what are the, to provide high availability? So, oh. Right. Right. So I've been reaching out to them and offering them access to this infrastructure. Oh, sorry, repeat the question. The question was there are multiple different edge plays in edge technologies in play, right? We got Starling X, we got Akrino, we got K3S, we've got a bunch of different ones. So are you asking which one is going to win? Yeah, I'm not an expert in all of them, but they all have different goals, right? Some of them are aiming to run in mobile devices or smaller devices. Some of them are supporting virtual machines, and some of them are supporting containers, so there are different plays there. Let's see, so yeah, it's a little bit too early to tell, and they're all going in slightly different directions. Yeah, the back.
Just a quick clarification. Is Packet using Vapor's container data centers to put your software in, or are they two separate containerized data centers?
So some of them are in Vapor containers, yes. So the Vapor IO is the company that owns the physical container and then provides the backhaul networking back out of those containers across the internet. Sure. Was there another question over here? No? Oh, Seth, yes. So I'm not sure if I heard your whole thing. Could you just summarize it and maybe say it a little bit louder? No. No, we've just been deploying the regular deployment using KubeSpray to go out. We haven't played with any type of network function virtualization or any type of telco applications. Yeah. So I know a lot of the edge plays are focused in on telcos and managing telco traffic. We haven't been involved in that. We've just been looking at use cases like CDN acceleration and moving more traditional compute towards those edge locations. But I do know that Starling X is definitely interested in those more telco-focused functions. Yeah, sure. Okay. Well, it sounds like the keynotes are starting, or the doors are open. So I'm happy to hang around here, answer any questions. If you want access to some of this infrastructure, come see me. Did you have another question? Yeah, go ahead.
So with this technology, each company can developer can be or developer able to control some part of the mobile network. For example, centralizing. Can we define this in edge so that we can allocate the number of bandwidth or speed that we require from the application?
Okay, so the question is, do you have access to the actual spectrum to allocate how many channels are allocated and how much bandwidth you have? As a normal user, no. You would come in and you would connect into whatever channel your devices are. There's nothing to say that you couldn't go to federated wireless, and if you have your own devices, and because they're the controllers, the government there are 3 players in the United States, and they're one of the ones that are controlling that spectrum and working with the device manufacturers. So there's nothing to say you couldn't contact them and say, yeah, I want to be able to, my device use more spectrum or to have higher bandwidth than. As a developer, it would be the same process. Yeah, talk to them. Yeah. Otherwise, you would just connect in with whatever channels your devices are using. Yeah, but yeah, you could. You could also go and get, I believe, experimental access to the spectrum and work through the government agencies and be able to use it in that way on your own.
So in the Alliance program that is mentioned there, how do we able to experience the edge computing? For example, I deploy my
Yeah. Right, so the question is, how do I use the Edge Alliance program? So the Edge Alliance program will get you access to is devices that have been deployed, so wireless devices that are using the CBRS spectrum at the edge, at that cell phone tower, and it would also give you API access to deploy bare metal infrastructure at those locations, which then you could deploy whatever type of cluster or cloud you want to, or just your application directly onto the bare metal. So you'd have access to bare metal infrastructure that's connected into the cell phone tower, to the spectrum, to devices that are in that footprint of that cell phone tower. Okay, so the question is, can you simulate switching and going as devices go from one? Currently, no, because each of those areas is just a single cell tower. Yes. So, yes. Those are not acronyms that I'm familiar with. Yeah, sorry. But I'm happy to go and get it to one of the cellular guys and see if we can answer. Okay. If there's nothing else, thanks for stopping by.